I first started woodworking 6 years ago, and it's grown into my main hobby. My original senior project would have been working on boat restoration, but I decided to build a ping pong table. My dad and I have been playing it a lot on virtual reality, so this would definitely be used by my family. As is the case with most of my projects, I started by going online to research inspiration. I had to change several design elements and the wood types, but I really liked the look of this table and wanted to replicate it in my own design. I designed the table in SketchUp, a free 3D modeling software. Knowing the weight of wood, I would never be able to move the table if it was solid. My solution was a torsion box, which is a lattice of planks sandwiched between two layers of wood. I also planned to make the legs and net removable so it would fit in my house. After calculating the required supplies and estimating the cost, I was off to the stores. I got the rough lumber at Home Depot and went to a specialty hardware store for the walnut and maple. The final cost was a little over $300, but wooden ping pong tables sell on Etsy for over $5,000, so I think I'm under budget. Now I could begin construction. Plywood comes in 4-foot by 8-foot sheets, and ping pong tables are 5 feet by 9 feet, so I needed an extra foot of length and width. I laid the plywood out on some 2x4s and cut 1-foot wide strips with a circular saw and a guide. I used pocket hole screws to connect the bottom layer. Screwing together the plywood gave me a 5-foot by 9-foot sheet. Next was the middle layer, a lattice work of pine 1x4s. I set up a stop block on my table saw to make all the repeating cuts of the same length and cut the short pieces slightly oversized. I first glued and clamped the outer frame of the layer, then worked my way inwards. I marked and cut the short boards so that they would exactly fit in the empty spaces and nailed them in place so I could continue working while the glue dried. By sandwiching these boards between 2 sheets of plywood, any bending in the layers is pulled flat. Flatness is my ultimate goal, since a curve can ruin a ping pong ball bounce. After the middle layer was glued, I used a flush trim bit on my router to cut the edges flush with the bottom sheet of plywood. Next, I attached the removable leg mechanism. To make this work, I drilled 6 holes through the bottom of the table and drew the outline of a nut on top. I used a small chisel to chisel out a recess that the nut would fit into. The recess had to be deeper than the height of the nut, for reasons I'll explain soon. The bolts were slightly too long. I tried to cut them with a hacksaw, and when that didn't work, I just grinded them down to length. The nuts were pushed into their recesses, and I glued a block over each hole to prevent the nuts from escaping. When I make the legs, the bolts will be inset into them, sticking up from the top. This way, I can screw the legs onto the table. The room for the nuts to move vertically allows me to screw the legs into the correct rotation, and then the weight of the table pushes the nut up to sit flush on top of the legs. With the mechanism complete, I can move the top up on my workbench to attach the top layer of the torsion box. Just like the middle layer, I glued this layer on top and used the router to cut the edges flush with the rest. Now is the time for the visible top layer. I cut 4 squares out of 1/4-inch maple plywood and arranged them on top. I cut a rectangle out of a sheet of walnut plywood and used the table saw to cut it into strips. And here are the walnut strips I cut. After continuously making small cuts until everything was in line with everything else, I noticed that the walnut was slightly thicker than the maple. It was too big of a difference to ignore, So I labeled the walnut strips to not mix them up and took them to the planer, cutting small amounts off the tops until they were flushed with the maple. It was time for a glue up. I spread glue on the plywood and put everything heavy I could find on top to weigh them down. After the glue dried, I cut the outer walnut and mitered the corners to meet at 45-degree angles. Next, I had to cover up the exposed edges of all the layers, which I did with maple wood. The maple on the short edges was glued first. I couldn't clamp them due to the length of the table, but I screwed down 2 walls on either side of the top and drove wedges in between to provide pressure while the glue dried. The long edges were easier. I simply cut them to size and clamped them after gluing. Then I came back with the flush trim router and removed the excess wood. There were some gaps, so I mixed some sawdust with glue and rubbed it into them. With the top done, I moved on to the legs. I cut 2-inch wide boards of maple and walnut and planed them flat. Then I glued them together so each leg is half maple and half walnut. After cutting the edges square on the table saw, I chiseled out an area on top of each leg that the head of a bolt could fit into. Epoxy provided a strong adhesive to glue the bolts in place. When the epoxy was cured, I cut the legs to their final length and decided to round over the edges for a better look. With the legs finished, I moved on to the fine detail work of the net. First, I made the net holders that connect the net to the table. These were made of small strips which I cut on the table saw. For the net, I started by cutting the basic framework. I routed grooves down the middle of the frame for the net weave to fit in. The net was woven so the strips were cut thin enough to bend. I used wood glue for the frame, but the weave held itself together, so a couple of drops of super glue were sufficient. The final pieces were the connectors that allow the net to slide over the net holders. Slides down. It's really still tight, but it slides down. With everything complete, it was time for me to spend days sanding everything and giving myself respiratory problems. To remove dust from surfaces, I used a 3-step process of vacuuming, then wiping everything down with a sticky tack cloth, then rubbing mineral spirits onto all the surfaces. To determine which finish I would use, I made a board of samples and recorded bounce height of a ping pong ball. I chose shellac due to its ease of application and the fact that the bounce was only half a centimeter short of regulation. With everything sanded smooth and clean of dust, I brushed on the first coat of shellac. For the bottom of the table, I used amber shellac since I already had some and it won't be seen anyways. I just needed a sealer coat. After drying, I lightly sanded it and wiped on another coat. This time, I thinned the shellac with denatured alcohol to make it less likely to develop brush marks. After this coat dried, I sanded a final time and applied a final thin coat with a rag. Everything was finished but the top of the table, so my family flipped it over. Before finishing, I filled in any gaps I saw with wood putty. Then I used the same process to finish it. Everything was done, and my family and I maneuvered the table up the front stairs and into the house. I'm really happy with what came out of this project, but apparently, virtual reality ping pong is still better than the real thing.